primary side. Okay. So how you can transfer this input. We already into their impedance transformation that is represented by Z2 total impedance or
Good morning, guys. And today our topic is cascade control. Okay, so this is, this is the cascade control. Cascade control means there is a two loop. First one is the primary loop, and the second one is the secondary loop. So within this two loop, first primary loop working on a particular control system, and then the secondary loop working on the total overall process. Okay, so this is called cascade control. So you can from this picture you can understand these things. First, this temperature is taken care. Okay, this is the say heat exchanger, or the it is a heater only, and then this is our main product. Then we have to control the product temperature. Okay, so in this way we can control total cascade control system. Means there is a two loop. First loop is the primary loop, which is controlled a small range and a particular part, and the secondary loop which is controlling the overall control system. So this type of control system is called cascade control. Okay, second picture you can say this is the primarily it is taken. Okay, this is our primary. We are taking the temperature of this, and then we also in the secondary cases we are considering the heater, or it may be heat exchanger. Heat exchanger is done by your steam flow. Okay, uh, so this is called heat exchanger, and in this way we can control the secondary also. So this is our cascade control loop. Okay, I think you can get a glimpse of idea regarding this cascade control system. Now we are going for the details of it. Okay,
if you want to look at it G2,
so in details we are going for the cascade control system.
have you remembered the previous
Control.
Or the impedance transform? Z2 dash divided by Z2 equal to.
Look, in this cascade control system, first a primary loop is working. A primary loop is working.
Again, and the secondary side impedance transfer to the primary side.
Primary loop. Okay, and overall here is a secondary loop also, which can control total process. this is secondary loop. So in this primary loop, one small control system is going over, which is the prime things, and the secondary loop, it will control the accessory part, which is associated with the total process. Then this type of control system is called your cascade control system. Now we will go for just like a boiler diagram. Okay, you have seen here in this slide, there is a typical boiler diagram is there. Now we are going for the details of it. Say this is your boiler. This is your feed water channel. This is your feed water channel. You know it. This is called feed water. Normal. This is feed water.
Hello. Are you connected to previous class? Hello.
Say this is a furnace or burner. Actually, boilers are there is so many type of dividation, but generally we are divided into the two types. For this case, that is a water tube boiler and a fire tube boiler. Okay, in a, just for your better convenience, in a fire tube boiler, what happens? Uh, Say this is your total boiler. 1/3 of the water content is 1/3. Okay, and 2/3 is empty. 2/3 is empty. But my picture it is not showing that 2/3% is empty. Why this? Because another 1/3% is storing in the steam. Okay, and another 1/3% is for safety. Okay, so this 1/3% or sometimes it is more than this. Uh, this is 1/3 to 2/3. They as per our requirement. Okay, so in this way, these tubes are going on. These tubes are going on. In this tube, one part there is a boiler, means there is a fire. These are the fire. Okay, and another part here is the induced fan is there. This is called ID fan or induced fan. Induced fan, and here is another fan is there, that is called draught fan. Draught fan. Okay, this fan is induced air and this fan is extracting air. Okay, so what happens if there is a fire? Then through this pipe, all the fire or hot air will be circulating. Okay, and after then it will going to the chimney. Okay, in this way the
And that
fire
is the
tube
current
boiler
of
are
the
working.
of
Fire tube boiler are working. And what are the construction of the water tube boiler? Water in this water tube boiler, this is look like this.
value of indirect ratio. That is one factor
Okay, here this is called mud drum.
N1.
Mud drum, and this is
The current transform that is I2
steam drum, and another name is there. So whenever you fire on this steam will be, this area is totally fired. This is furnace. Fire is going on, fire is going on. So this steamer gathering over here, and these things are again, it is heated. That is called superheater. Then again heated, and it will go the turbine. In this way, it is working. And sorry. This is come to over here, and what are the water content just became cool, it will come to here. So that again this water is circulating and this steamer going on. Okay, in this way, this is the water tube boiler are working. So here we are generally working in this this is furnace, and we need two things. First one, we have to run the furnace. One is fuel, and another thing is your air. Okay, this is fuel, and here we need fuel, and another thing is need, that is your air. Look, if this is a petroleum fuel, then we need fuel is to air, that is 10. If it is a coal gas, coke oven gas, COG, then it is required 1:5 air. If you don't, if this air is not controlled, then it may caught fire over this fuel channel. So it is very important. Or it may be some briquette, that is briquette is made of some husk, that is paddy husk. It may be done over there. So what happens, here is some control is there. First one is that you have to control this temperature. What are the required temperature over there? And second one, we have to control this fuel also, so that if we need fast steam production, then we have to increase this fuel and air. And if we need less steam required, then what we need, then we just cut this fuel and air ratio such a way so that our requirement will be fulfilled. So in this way, these two things are, two control system are working. First, this temperature is controlling. This temperature is controlling as per your feed water. If the feed water is coming, then this temperature also down. And if we just control this fuel and air ratio or supply of fuel, then also the temperature will be varying. So there is a two control system are working. First one is feed water control, and the temperature control. Second one is the fuel control. If we require high pressure of this steam, then we just increase of this fuel and air. And if we have seen that is, say this is 80% open, but this feed water is coming very high, then 80% is not work properly, then we have to increase with 100% fuel ratio. If it happens that it is opening 80%, but feed water is very less, then what happens, this all water became steam very fast. Then we have to just reduce it, say that is 50%, so that what are the available water, then we can make it steam, because feed water ratio is going to very less. So you can see there is the two things are working at a time. This is called cascade. But in previous classes you have seen there is a, though there is a two loop, but this is not, this is a parallel loop. But here you can see one loop is dependent on the other loop. Okay, but in previous cases two separate loop are working, but here these two loops are dependent each other, and that's why this system is called cascade control system. So we are going for the control strategy, how it is working on. First, from this diagram you can understand these things. Look, this is your process.
Just tell me what is the volt ampere rating of primary side?
This is final control
V1 into I1 and secondary side V2 into I2
element.
So you will write this equation.
Means this is steam
V2 into I2. So that you will be
or water, and this is inner control element.
I2 you have given and I1 you have to provide. So you will find out the V2. Okay. So this point, that is volt ampere of two sides are equal. That is V1 and I1 equal to V2 and I2. Okay.
So that is inner variable.
And last point is impedance are transformed in the proportion in the square of the turns ratio. That means Z2 dash is equivalent of the secondary side impedance towards the primary side. So that impedance will be write as the square of the turns ratio, that is N1 by N2 whole square into Z2. Okay. So let's write here in the point form, that means impedance can be transformed
Okay, this is inner loop. Okay, say the temperature and the feed water controlling is doing here, but another loop is working here, that is given by the
multiply the actual impedance, that means Z2, actual impedance of the secondary side.
That is called outer variable measurement. Means this is a feedback path.
Impedance
Variable measurement.
impedance of the secondary side. The secondary side, that means Z2. And a square of the turns ratio.
And it is connected to here. So this is your process final output.
ratio. Okay. That is Z2 dash equal to Z2 into N1
Okay,
by N2
so
whole.
you can see here two loops are working. This is inner loop, this is called the primary loop, and the outer loop is called the secondary loop. In this case, first in our system, if I do this, first fuel,
N2 by
if
N1 whole.
it is called heat exchanger,
N2 by
it
N1
is
whole
heat
square.
exchanger, then it may be steam, or it may be for the I am saying that steam, where the small boiler are working, say your dyeing plant, your hospital, nursing home, etc. In your food production, where our hot water are required and sometimes steams are required, then what happens, we are just making some small boiler, generally capacity of 5 tons, and these steams are working. Okay, then steams are used for making this water hot. And whenever some turbine or power system, power generation are required, then this type of if this is a 5 tons, then this type of boiler are became 200 tons capacity. Okay, just remember, then we are directly applied this fuel. Okay, means fire tube, then we are applying fuel at it, actually this is a fire tube or water tube, water maybe, but in this case fire tube boiler, small fire tube boiler are required, and we are doing for the steam exchange or fire exchange, whatever maybe is required. But normal cases in your hospitality, on your food production area, there we are using the small boiler, that is 5 tons. But in your power generation cases, we are applying this is 200 tons, and just like this, not specific this, but this ratio you can imagine. Okay, so here you can see this feed water and the temperature is the first primary loop. And then we are also, if we go for this fuel and air ratio, this is one loop, and this loop also here, this is called outer loop. Actually this is called a secondary loop in this secondary control. In this way, these cascade control systems are working. You can realize these things. Feed water and this temperature, actually this temperature is a ratio. This is a this is done in the primary section. This is our prime things. And if we change or vary this fuel also, then it will also be affected. So you can see this process system, this is our prime things. But if we change this ratio, means first time we are applying 50% fuel, then we are applying the 80% fuel, then we are applying 90% of fuel injection, then it will must change. Because if I give some heat, much heat, first time heat is temperature T1 degree, then temperature is, sorry, this is greater than, second time temperature is T2, third time temperature is T3, then the steam generation must be high. First time that is P1, second time P2, third time P3. So this is also a loop, this is the outer loop. And in this case you can see, if the feed water is changing, say first time feed water is W1, then steam production also, that is P1, that is P1 dash. If that is feed water is W2, then steam production will be also the P2. So if first time that is W1, then W2, then W3, that is the feed water, feed water, then what happens? Then temperature also vary. So we have to maintain simultaneously, that is feed water and the temperature, and the fuel ratio for the temperature, maintaining the temperature, that is input temperature, and this temperature means feed water temperature is the output temperature. So if we want to meet the position, for the steam we need minimum 100 degrees centigrade. If we want to meet this temperature, then look, there is a two temperature is required. First, this temperature, that is 100 degree temperature, and this is the fuel temperature, means the boiler temperature. It may be more high, that is more than this is high, that is this type of temperature is required. So we have to control these two temperature at this boiler, that is 100 degree centigrade. Sorry, this is the water temperature, and the outside of this boiler where the furnace is there, this section is called the furnace or the combustion chamber. Rather it is called combustion chamber because furnace temperature is much high, where the irons and the metals are going to melt or going to into heat, and this is called a combustion chamber, and this is the uh, water, this is under the boiler, okay, water tube. So these two temperatures are controlled over here. Look, this has must some ratio. If this is not controlled, then if you control only this, then it is not fulfill your requirement. Okay, and boiler section, this output stream is very much crucial. If you generate more stream, then what happens? Boiler may be cracked, or your safety valve will be open, then it will go outside. Okay, so you have to maintain such a way as per your requirement, that much you have to generate. Otherwise, it may causes is fatal, or it may causes just loss. Okay, so here these two loops are working. This type of things are called cascade control loop. So guys, if you have any question, you may ask me. Otherwise, I am going for the just some specification and features of these things. Okay, if look, if we go for the total control system, for the control diagram, you can see this is input, this is process 2, process 2, or it is called secondary. Okay, and this is process 1.
और कौन सा पैरामीटर दिया हुआ प्लस डेंसिटी प्लस डेंसिटी इक्वल टू 0.9 और कोई पैरामीटर any other parameters given in problem except number of times that I want to and plus frequency equal to PTR. You can put this type at over, you may put this type in over also. Okay, this thing is you can do this. Whatever, some book you can get in this way, some book in this way. This is your output, this is your input. Okay. So let's some features. What are the features? Now,
first thing, this is more than one measurement is required, but one manipulated variable.
area
More than
if you put on the
one measurement
used to be an equation, and we get
measurement
area
more than one measurement is there because there is a two feedback, but one manipulated variable, but one manipulated variable, that is temperature.
and
Manipulated variable.
quantity.
Okay. Look, two measurement is required because for the primary loop, this is primary loop, this is the secondary loop. So two measurement is there, but one output means one manipulated variable, that is temperature. Okay, we have to concern the steam temperature. So one thing is manipulated variable. The output of the master controller serves as set point for the slave controller. You can see this is the master, this is process, or it may not be process as per your requirement. Then you can see this, if this is a master and this is a slave, the output of this master controller is the input of this slave controller. Okay, so it is given over there. Especially useful eliminating the effect of disturbance that move the system slowly. Look, they are talking about the disturbance. Means actually, if there is a normal fixed ratio, so feed water is 10% and steam output is 10%. So this is a static ratio and we are just controlling the temperature only. Then no problem is there. There's only one loop is required. But here this is called disturbance because first time this is 10%, then this is 20%, again this is 10%. It may be vary. So this is called the disturbance, which we have deal with this your feed forward control system. Feed forward control system, we are also applying some control strategy as per our experience, as per our rule base. But here, if this is not occurred because we don't know how much feed is coming. Sometimes it is 10%, sometimes it is 20%, sometimes it is 30%. So varying. So this is called disturbance. So for this disturbance, we are directly apply this cascade control system. It will handle very effectively. Look, in your feed forward control system, only one loop is there. There are also some disturbance, but we do not control the disturbance. We just measure the disturbance, then apply the control strategy, apply the feed. But here feed also, as if whenever feed this disturbance is coming, then we also control this feed. So that's why this is called cascade control, and this is very much effective for this type of disturbance because this variable is varying. This is feed are varying. just distinguish between feed forward control system and this is the cascade control system. So this is 4. Inner loop has the effect of reducing time log in outer loop so that cascade control respond very quickly and improves dynamic performance. Okay. Now second point, decreases variation in primary variable. Okay, that is 6 point. It will enhance stability. It is characteristic. Yes, okay. That is 7. In it is sensitive to modeling errors. This is because if any errors is coming, then and then it is controlled, two-way control. Then it will very sensitive for this error. And it was 7. And then 8 number point is the secondary controller correct the error. Correct Arvind arising within secondary loop before they affect the primary variable. Okay, secondary controller correct the disturbance arising within the secondary loop before they affect the primary variable. Secondary controller is mostly with high gain value. This is tuning of this single channel mode is simple, and moreover the offset associated proportional mode can be easily removed by internal action in primary. Okay, so this is the features of cascade control system. So guys, if you have any question, you may ask me. So up to this, your controller part is over. Then we will start your instrumentation part from the next session. Okay, thank you. Have a nice day.
Thank you, sir.
Okay, thank you. Just 1 minute.